Here we have an example. We are given the initial position x0 and initial velocity v0 for the oscillating body. Determine the phase angle phi and the amplitude AA at time t0 equal to 0. First step is to use the ideal equation. Recall that the initial values of the position and velocity at time t0 can be expressed in terms of its cosine and sine functions. We then take the ratio of the initial velocity over position and arrive at a value of negative angular frequency times tangent of phi or phasor angle. If we take the inverse tangent of the function, we get an expression for the phase angle phi, which is the tangent inverse of the ratio of the negative v0 over angular frequency times initial position. To solve for the amplitude A at time t0 equal to 0, we square the equation for the initial position and velocity. We then see that we can use the identity function by summing the squares of cosine and sine, which is equal to 1, and we get an expression for the amplitude. We see that the amplitude is equal to the square root of the sum of the squares of initial position plus the ratio of initial velocity over angular frequency.